So you're not sure you can describe how Aristotle, Copernicus, and Galileo described motion. Let's see what we can do to help. In this quick review, I will go over each of the scientists and their views on motion. Aristotle, approximately 300 BC, Greek philosopher, observer, and scientist. Aristotle viewed the world around him, categorized the elements that things were made out of, and described their motion. In Aristotle's view, there were exactly two types of motion. There was natural, and there was violent. Natural motion was based upon the object's elemental properties, meaning that objects would tend to go where their elemental properties drove them to go. Let me give you an example. Let's say that we have a piece of wood that is burning. I can tell by watching that burning wood that it is made out of air. I can see the smoke. And it is made out of earth. I can see the ash. Now, these elemental properties go naturally where they need to go. Elemental properties of air naturally go up. Elemental properties of earth naturally go down. According to Aristotle, natural motion was always up and down, depending upon the properties of the elements. Now, the other type of motion was violent motion, and violent motion required a force. It was any motion that happened side to side, and forces were required for violent motion. This description of motion lasted for a better part of 2 centuries, and it actually was part of the driving force behind our view of the earth and its surrounding areas. According to Aristotle, the earth was in the center, was stationary, the center core, of course, naturally, earth element combines towards itself, and the air, the ether, was surrounding it. This gave rise to what we call the geocentric model of the universe. Travel forward to the early years of the 1500s, and we have Nicholas Copernicus, who was a Renaissance mathematician and astronomer, who truly changed our view of the universe. Now, the geocentric theory was what was being taught, but through his observations and through reading of other scientists, he realized that the math did not work, and instead, in order to make things more elegant and to better predict future events, he created the heliocentric theory, which took the Earth out of the center and replaced it with the sun. Now, this changed our view of motion because now the Earth was no longer stationary, was no longer the center of where all Earth element properties would go, and it changed how people viewed their position in the Earth and on the world and as a part of the universe. Next we come to Galileo. Now, this little cartoon here at the top shows the difference in opinions between the Aristotle's philosophies and those proposed by Galileo. According to Aristotle, forces were required to keep things moving. However, Galileo, through some experiments, decided that that was not right, that forces make things stop or change their direction. Inertia, the resistance of an object to change its motion, keeps things moving. Now, there's a thought experiment using what is referred to as the Galilean ramp, where if you have a bowl where initial height here, and you have a steep angle of a steep angle, and you drop a ball down, you can watch, and in the absence of friction, the ball would go up to the exact same height. Now that was an interesting idea, but what would happen if we stretched out our bowl? Well, after experiments, we found that the angle of the opposing incline really doesn't matter, that the ball, even though it has to roll farther in order to attain the same height, does so. Now, what would happen if we stretched it out even farther? We find that it is the height that the ball rolls up to that causes it to stop, not the length of the ramp. So what would happen if our ramp continued on straight? Well, what Galileo surmised was that our object, our ball, would simply keep rolling, and rolling in a sideways direction. This was completely different from what Aristotle had observed or understood, but it better described what's actually happening. And then we come to Sir Isaac Newton, who, as he puts it, standing on the shoulders of giants, takes all of this learning that has happened before him and consolidates it down into 3 very elegant and simple laws.